In this video, we're going to look at right triangle trig review. So the first thing we want to do is we want to be able to remember how the trig ratios are defined, and that's where SOHCAHTOA comes in. SOHCAHTOA just allows us to remember the definition for sine, cosine, and tangent. So when we look at the definition for sine, the sine function is defined as the opposite side over the hypotenuse. It's just the ratio of those two sides. The cosine is defined as your adjacent side over the hypotenuse. And then we have the tangent function, and the tangent is defined as the opposite side over the adjacent side. Now we look at this triangle. So we're going to start from angle A. The opposite side, so let's say opposite A, would have to be, we'll call this lowercase a. And then the adjacent side, which is next to angle A, adjacent to A, would have to be then called side B because it's opposite angle B. The side that's across the right angle is always called the hypotenuse. So this is the hypotenuse, which we'll call side C. Looking at the definition for sine, it's opposite over hypotenuse. So the sine of angle A would be A over C. So we put down A over C for the sine. The cosine would then be B over C, and then the tangent would have to be opposite over adjacent, which is A over B. Now, the thing about this is that when we go from a different angle, let's say we're going to go from angle B now, then the side across from that is opposite angle B. So now that's going to be side B. Hypotenuse stays the same, but the other side then that's next to it is adjacent to angle B. So side A is adjacent to angle B. Therefore, the sine is opposite of our hypotenuse. That's going to be then B over C. So we put down B over C for the sine of angle B. The cosine would be A over C, and then the tangent would be B over A. And that would be your definition for sine, cosine, and tangent. Now we're going to use these definitions to identify and find angle measures as well as side lengths on these triangles. And we're going to do a couple examples together. So here's our first example. Nicole is out flying a kite. She lets out 125 feet of string at an angle of elevation of 30 degrees. So the 30 degrees is from a horizontal going up. That's an angle of elevation, going from the horizontal up. How high above the ground is the kite? So we want to know the distance above the ground the kite is. And they're giving us a hint that Nicole's arm is extended 6 feet above the ground. So we just need to remember to add 6 at the very end of the problem. So I circle the angle that I have, which is 30. I look across the opposite side and I say, well, the side over here would be called the opposite. I'll call that X. The side of the 125 is across the right angle, so that's my hypotenuse. So then I think opposite hypotenuse, and I look at my trig functions, opposite and hypotenuse, and that's a sine function. So therefore, I'm going to use the sine function to identify and find side X. So I start to write my equation out, and I would say that the sine of the angle 30 degrees is going to be equal to X over 125. And I'm going to try to solve for X now. A good habit to be in would be to put the sine of 30 over a 1, and then you cross multiply, or just multiply by 125. So it's going to be 125 multiplied by the sine of 30, and that's going to equal our X. Now, on your calculator, then, so we'll take out our calculator and look at how we could type that into our calculator. And basically, you just need to make sure that you're going to be in degree mode. So on our calculator, we want to click the mode key and make sure that our calculator is switched to degrees. And we hit enter. So it's in degree mode. Now all I do is I type in 125, and then the sine key is right here, sine of 30. And I type that in, and I get my X value to be 62.5. Now remember, person was 6 feet tall, so we got to add 6 feet to that to get 68.5 feet as the total distance. So the answer to this question would be C. So the total distance that we would be from the ground would be 68.5 actual feet. So that's going to be the kite all the way down to the ground itself, because we added the 6 feet plus the 62.5 that we had initially. So that's for our first example of trigonometry. Now let's look at another example. This time what we are told is that we're supposed to find the length of a shadow cast by a 50-foot flagpole if the angle of elevation to the sun is 27 degrees. So this time we are going from this 27-degree angle right here. So I'm going to circle that. The side across from that, we call that the opposite. And the shadow length that we're trying to find is the adjacent. So we're dealing with opposite and adjacent. I'll call this the x because that's what I want to find. I want to find the shadow length. Opposite and adjacent, that's in a tangent function. So I say I'm going to take the tangent, 27 degrees, has to equal 50, which is my opposite side, over x, which is my adjacent. I put this over a 1, and this it's especially important in this case because when we cross multiply now, what's going to happen is that we need to do this to be able to solve for the x correctly. We end up with x tangent of 27 equals 50. We then have to divide by the tangent of 27 degrees on both sides. So when I type this into my calculator then, I'm going to basically just type in 50 divided by the tangent of 27 degrees. And I hit enter. So my answer that I end up with here is 98.13 is my answer, and that's going to be in feet. So I look at the answers that are listed. I'm looking for 98.13. Well, they're not there, so my answer is going to be D, none of the above, because none of them match in my situation. Now be careful if it does match, because it could be that you still did something wrong, because normally they're going to list answers that with the most common mistakes that people make on the problems themselves. Okay, let's try one more question with trig review. Right triangle trig. This time you need to build a wheelchair ramp in front of your home for your ailing mother. If your ramp needs to be 15 feet long and have a height of 3 feet, what is the angle with the ramp makes with the ground? So this is the angle we're trying to find. We'll call that x. The sides that we're dealing with here are the opposite and the adjacent. So if I'm dealing with opposite and adjacent, it would be the tangent function. So the tangent of x is going to be defined as 3 over 15. To calculate the value of x then, this is where I'd have to say, well, what function gives me the angle? And that's going to be the inverse tangent. So I'm going to take the tan inverse of 3 over 15 on my calculator. So when I pull my calculator out, this is extremely important that you're in degree mode again. And when I type this in, I'm going to do second tangent. That's what gets me the tan inverse of 3 divided by 15. And when I do that, then I would end up with 11.31 degrees if I rounded. I will then look at the answers that are listed, and I see that the correct answer would be D.